Hi everybody, it's Steve Iverson here with Finished Basements Plus. Today we're at a customer of ours home in Ann Arbor, Michigan, and really just want to kind of tell you the story about this project. This is a customer who called us, wanted us to come help them finish their basement. As you can see, they've got the drywall up, assuming there's stud work and insulation behind there. All they wanted us to do is come in and finish the drywall, install moldings, and then move on. Upon further inspection, and what we're hoping to demonstrate today, is that we believe when we open these walls up that we are going to find signs of water, moisture, and probably even mold. Okay, so before we go and take a look at some of the exterior walls here, we just wanted to put a control in place here and test the interior walls for the moisture content in the material. I have a pin tester here that is going to tell us what kind of moisture content is in the drywall and in the stud wall here. So I'm getting readings of about 14.5% in the drywall itself and 11% in the wood studs. So what we're going to do now is we're going to go over and we're going to test different portions of the basement wall and see where the moisture level is, both on the surface and inside the material itself. Okay, so this is our chosen location, our first location that we want to test for moisture. First, I want to just tell you a quick story about this particular basement, and then we'll move on to the testing. This basement has had a couple of water events. We know that. We can see the witness marks here on the drywall where the material itself has wicked the moisture up. The customer that we're working for now took bleach to spray down the drywall. There have been articles saying that's what you should do. What those articles don't tell you and what the bleach doesn't address is what's behind this wall. And we're about to find out. So let's test. So we'll start at the top of the wall here. And we're getting a measurement of 15%, not too far off from the interior wall. Let's go about halfway down. We're up into the 25%. I have a moisture alarm on this, so it is going off, 25.1%. And down here at the bottom, the percentage just went over 50%. So the next thing that we're going to do is we're going to pull this sheet of drywall down and see what's behind here. Okay, so now that we have removed several pieces of drywall, we have found several leaks. We have the worst leak in the basement is right here. It's a foundation crack from top to bottom. The bottom plate of the wall is actually wet and moldy. The studs are starting to grow mold up the inside edges. The insulation had mold on it at the very bottom. And then the drywall on the inside has mold growth on the bottom working its way up. And this is where the homeowner had washed the surface down with bleach, which there wasn't any mold on the surface, but behind the surface there was mold growing on all the organic materials that this basement was built out of. Okay, so a couple of other areas that we want to point out to you that are not currently leaking, but are definitely a source where water can infiltrate the basement and become an issue, a big issue. So Sump Pump, this customer's home actually did have a sump pump failure. The backflow valve froze, and then the water started coming back into the basement, which led to some of what we've seen here. Also, You'll see some witness marks, some water witness marks right around the window area. The window, well, at some point this window was leaking. It may not be an active leak, but at some point it was leaking. Okay, so we removed another sheet of drywall at the other end of the basement, and we actually discovered three issues. One, another foundation crack lurking behind the wall. Is actively leaking because we found water and mold at the bottom of the wall. And also, this plumbing supply line that's leading to the outdoor has frozen and split and was dripping water into the basement, which led to the mold growth on the surface of the drywall. Another point here to make is part of the reason that this pipe split is there's no bond insulation up in the cavity here to keep that cold air out and keep the cold air from filtering through the bond insulation. So this was a double whammy. We have a foundation leak, we have a plumbing leak, and we have surface mold on the drywall, on the organic wood, and the fiberglass insulation. Okay, so further talking about the wrong materials, I just wanted to dive back into fiberglass insulation. First and foremost, reading through the code book, you're going to find, and most contractors don't know this until they get into the inspection process and they get red tags and they have to do things over again. Any type of vapor barrier on the insulation itself is strictly prohibited and against the code. So this has a paper-backed vapor barrier made by a very large company that makes a lot of insulation. And this product is not suitable for basement finishing. Not only is it organic in that it can wick moisture and potentially grow mold on it, the vapor barrier is obsolete. There should be no vapor barrier in basement insulation, not to mention the fact that they're placing the insulation in between the stud cavities. So every time we have a stud cavity, there's a cold spot in the wall. Insulation, cold spot. The other thing is, if you read this very carefully, you're not getting R13 out of this wall unless it's encapsulated on both sides. And it's not. The back is wide open to the cold cement wall. So there's the wrong materials and there's the wrong application. Okay, so what we've demonstrated today, hopefully, is that water and organic materials don't mix. There's definitely the wrong materials that can be used in a basement project, like fiberglass insulation, that if any moisture or water come in contact with it, while this says R13, when it's wet, it's 0. Wood studs, that's an organic material that can grow mold on it, but it can also wick moisture up into the studs. So maybe there was a small leak at the bottom. There are witness marks and water marks all the way up, halfway point into this wall. And then obviously the drywall is soaking up the water and the moisture that leaked into this basement, probably on several occasions. But now this once 10-pound piece of drywall weighs probably 15 or 20 pounds because of the moisture that it's holding. So all of these products, all these materials, drywall, wood, and fiberglass, soak up the moisture, hold the moisture, and don't allow anything to dry out, but do offer a great opportunity for mold growth. Okay, so to continue the story of the basement with the wrong materials, upon further inspection after the demolition was complete here, we pulled out all of the wood studs, all of the fiberglass insulation, all of the drywall, which did have mold on all those pieces. But we also discovered, after getting all of that material out of the basement, 10 foundation cracks, of which 6 of them are actively leaking. This is all leading to the mold growth in this particular basement. So what was once thought to be a basement that was ready to be finished, just finished the seams, add some molding and some paint. Turned out to be a basement that needed to be demolished and repaired before finishing properly.